Hello everyone, and welcome back to Ewan's Buzz. In today's video, we're going to be restoring this Tektronix oscilloscope from the late 50s to early 60s. So, let's get right to it. So this is a Tektronix 502 dual beam oscilloscope. So dual beam basically means it has two channels. Now, this oscilloscope still works very well, actually, considering how old it is. Now, these oscilloscopes were manufactured from 58 to I think 61. Don't quote me on that, but I'm pretty sure that was sort of the date when they were manufactured. But there is a TechWiki article that you can take a look, which will tell you everything about this. I'll leave a link to that in the description. Now, this oscilloscope works 100%, but it could use a little bit of TLC. So, it lived in a woodworking garage for a long time. So, it is full to the brim with sawdust. So we need to clean it out and just take a look at it. But it does work, so let me plug it in and get it showing to you. Well, and show it to you working. Okay, so I've got the oscilloscope running, and you can sort of see the screen is fading in and out. That is because the intensivity pot is very dirty. Because you see, so it doesn't look too bad here, but it's very all over the place. So it looks very bright on camera, but it's not. But you don't want to run an oscilloscope tube very hard. Reason being is because it can burn out the phosphor quicker, and you don't really want to do that because you shorten the life of the tube. And these tubes can be very hard to find, so you don't really want to burn out the tube. But if you look at it, it's working. We can do some adjustments here, and you can see I've just got like a little frequency generator that I built in one of my previous videos, and you can see that this is a sine wave, and I can make it wider, and I can make it smaller. I can do that as well, and I can make it bigger, but I'm not going to make it too big because then it starts to distort. I think that's distortion, but I don't quite know. But you can see it's definitely working. Let's take a look at a triangular wave. Turn that down. There we go. And there is a sawtooth wave, or triangular wave. And you can see it's fading again because of this intensivity knob. But there's a triangular wave. Now let's take a look at a square wave. So the square waves, what you have to do is you have to change the input. And now you can see my probe really does need to be calibrated, as those should be flat, not like that. So let's grab a probe calibrator tool, which is in here, which is actually this little thing right here. That's a probe calibration tool. So let's get it out, and we're going to calibrate this probe quickly. So whenever you're using an oscilloscope, you always want to calibrate your probe. And that was one thing that I forgot to do. Now that is interesting. That is very interesting. Oh, it's a dodgy connection from the probe to the oscilloscope. But now you can see that is how it's meant to look. Not all wavy like that. So that is a proper square wave right there. And the amazing thing is, this oscilloscope is over 50 years old. And it still works. 100%. Needs a bit of TLC, of course, as you can see. It's doing silly things. But it still works. And it shows just how serviceable and durable they made these oscilloscopes. Because I've got an oscilloscope, which is the Tektronix 464 storage oscilloscope. That thing was built in the 70s. Not about 20 years from when this was built. And it is so much smaller and so much more complex. It is crazy to work on and very, very complicated. This is a lot more simpler. It's only, I think, 2 megahertz, which isn't a lot. But for a basic electronics guy like me, that's pretty much all I need. But this is just one beautiful oscilloscope. So in this video, we're going to be restoring it together. So now you see what it's doing. We're going to clean all the potentiometers, and we're just going to clean out the inside as it is full of sawdust. So let me show you the inside of it. But before that, it's got a massive fan in the back, and you can hear it running. Listen. Maybe if I take my mic off, you can hear it better. There you go. So, yeah, it's got a big fan, keeping some very cool little things inside of it cool. So, we're going to open it up, and let's take a look inside.
My stoner mind.
So I decided to go handheld just to show you the sheer scale of this piece of equipment. Now, the really cool thing I was telling you about are these little guys. Vacuum tubes. Now, vacuum tubes are really, really cool. They're basically the transistors of the olden days. As you can see, this oscilloscope does have one or two silicon or maybe germanium, or it could be selenium transistors. Whoops. So it does have some solid state components. Maybe those could be crystals. That I definitely think is a solid state. Maybe it's a diode or a transistor, but I don't quite know. So, but what I do know is that these are vacuum tubes, and they are incredibly cool. Now, the interesting thing about this oscilloscope is it has 48 vacuum tubes inside of it. And that is a lot. I mean, a lot. So you can see there's a couple here. There's some more over there. There's a whole lot more underneath here. You can see them in there. Then, if we come around to this side, you can see some more down here. Well, those are capacitors. But there's definitely some more vacuum tubes here. And I'll come around this way so you can see. And just flip the camera around. There we go. There's a whole lot up here too. Yeah, a lot of vacuum tubes in this oscilloscope. And since it was just on, I can feel the heat emanating from it. And it's still pretty warm. And that fan I was telling you about, that sits over here. It's a little bit stiff. Actually, it's not too bad. Now that I look at it, that's actually not too bad. You can see there's a fan here, quite a beefy one, so that actually pulls air in and blows it out the vents in these panels. But also, I'm sure you've noticed something very out of place. Look at all of this sawdust. Isn't it amazing that it hasn't burst into flames yet? I'm just going to put this back in there for now because I'm going to blow it out with the air blower. But there is a lot of sawdust. You can actually see it everywhere. So let's clean that out and get a better look at what's inside this oscilloscope. And then I'll give you more of a in-depth look at what everything does and where everything goes. So I need to take off some parts before we can clean this thing, because this front panel actually comes off. And as you can see, there's sawdust inside of there as well. So there's a lot of sawdust that needs to come out. So let's go outside and clean it up. But first, I'll take this off. And to take this off, it's actually really simple. Let me do it on camera for you guys. Undo these nuts over here. And that can take some time because they're very long. Or the threads are very long, not the nuts themselves. But with the great engineering, they usually just slide right off. They come off like this, you see. So they come off really nicely and easily. And then you do just need to hold on this aluminium plate just so it doesn't fall off. But then once you get them off, and sorry about the terrible camera angles, it's because I've gone handheld. I'm still getting used to my new camera. But we take this off, and that is the aluminium faceplate that covers the tube. You can see more sawdust. We'll put that here. And here is the actual graph that would be on the oscilloscope screen. And here it is. And this is just a perspex plate, no glass. But then, now that that's over there, you can actually see the oscilloscope tube. And isn't that one beautiful tube? I mean, really, that looks nice. And these little globes here, these are for the scale illumination. There's 2 of them. And they both still work. Crazy enough. So let's take this outside and give it a good clean. So after a nice gentle blowout, it's looking pretty good. That's all the dust that came out of it. All good dust, so it should go away, I hope. But there was a lot of sawdust in there. But otherwise, the scope's looking great. Now you can actually see what the labels say on things. So, it's a bit bright now, but once we're back inside, you'll see what it's saying on these labels. But otherwise, looking pretty good. Looking pretty good. Okay, so one thing I forgot to take off, and I forgot to show you guys, was this actually has a big filter on the back. So let's quickly remove it. So this filter is to prevent dust like that getting in. I have no idea how that dust even managed to get in, but you know how dust is. Has mysterious ways of getting into everything. More sawdust. Isn't that crazy? So this is a very interesting filter. It's actually just metal. So I don't know where one would get a new filter like this, so I'm going to blow it out with the blower again, and we're going to take a look at more of the electronic side. But you can see machined aluminium blades on this oscilloscope. Isn't that some high quality there? So one thing I did forget to show you was this. This is not meant to look like that. This has actually been a bit of a DIY sort of botch, and it wasn't done great. I don't know who did it, but it wasn't done great. As you can see, it's been held together with insulation tape, which is already coming off, as you can see here. It's already coming off. And I don't know if it was wired correctly via live and neutral on these prongs. Now, this type of connector, I asked some of the very clever people on the Tektronix Facebook groups, and, well, on the one Tektronix Facebook group that I'm in. I asked them, and they said that this is actually a United States style plug, but you just use an extension cord, and you plug in the female end of the extension cord in here, and then you plug the other end into the wall, and then Bob's your uncle, it works. But that's not really the case, because I'm in South Africa, and our plugs look nothing like US plugs. Our plugs look like this. So, sort of similar to the British plugs. But they're very different. So, and it would also be very hard for me to get a hold of a United States style extension cord. Like, look, it would be easy because I could just say, hey, or ask my aunt and uncle or the friends I have in the US, ask them, say, hey, could you ship an extension cord out to me? But that's so impractical. And the only type of US style plugs I have are those weird multi-plugs, you know, that take a whole lot of different ones, and I don't want to be using one of those on here. So what I'm going to do is I'm actually going to take this old cable off, get a nice new cable, put solder it on live neutral, and solder on the ground, because the ground just goes to the chassis here, and put a big thing of heat shrink over it. It just seems like the best thing I could think of doing due to my circumstances currently. Because I thought of putting an IEC connector on there, but then I decided, you know what, no, because then I'd have to modify the case, and I don't particularly feel like doing that, as I don't want to damage it either. So that's the back of the scope, so let's start cleaning those potentiometers. So here we are looking into the more insides of the oscilloscope. Now, here's the potentiometers that I need to clean. It's a selection of them, but it's mainly the ones that sit underneath the screen. But now they are specially covered, which is very interesting, except the scale illumination one. Now, the scale illumination is actually this very long rod here. I don't know if you can see me pointing at it, but let me zoom in a little bit. It is this rod over here, which is, I think, a fiberglass rod? Yes, they are fiberglass rods. And now that goes to the high voltage circuits right at the back of the oscilloscope. because those high voltage circuits need to be isolated. So that's why there is a fiberglass rod like this long isolating it. That's pretty long. But the potentiometers we need to get to are actually behind this little cover, and this thing weighs a ton. So you see there's this cover here. 2 screws are held, well, there used to be 2 screws there. I don't know what happened to the other one. But there's screws that hold this little cover on, and I actually need to actively hold this, otherwise it will fall. But there's 2 screws holding on that cover, and then we're just going to clean those potentiometers, because I think those are the only ones that really need cleaning. Reason being is you don't want to clean the very sophisticated ones that are like down here, as those are very finicky, and they've been tuned so finely that cleaning them with just a regular electronics cleaner can throw them off balance. So usually you'd use isopropyl alcohol to clean them, and make sure it's 100% isopropyl alcohol, because that can also throw them off. All of this information that I've learned has been from the TechWiki site, and also all the amazing people on the Tektronix Facebook group. So thank you so much to them. Now, I'm going to remove this, and I'm going to clean the potentiometers over there, as that is the intensity, that's what I was looking for. So the intensity and all the other ones, so intensity, focus, things like that. So I'm going to quickly clean those, and then we will put it back together, test if it works, and hopefully that fixes our problem.
My stoner mind.
Okay, so I've cleaned the potentiometers, and I've blown a bit of warm air on them using my soldering station, just to make sure all the contact cleaner evaporates, as I don't want it to stay in there when we turn it on. So as I've got it now, I want to just turn it on to make sure everything is okay, and to see if anything improved, which hopefully it did. But now, this oscilloscope, I feel like it was stored somewhere funny, as it's got the weirdest, nastiest stuff all over some of the connectors. I mean, look at that. That's pretty gross. Don't know what it is, but it's just kind of nasty. So I think before I turn the oscilloscope on, I'm just going to clean out these. So I'll do that real quick. That shouldn't take too long. Then I will just put this black thingy back on the tube, as I did clean the tube as well, so we can actually put that back on right now. So that is the wrong way, as the deflection, as the spots for the lamps are not, you can't see the lamps. Let's actually give the light globes just a little bit of a clean as well. There we go. Light's all clean. And then, yeah, so there's just this nasty gunk all over it. Don't know where it came from, but it doesn't seem to be causing problems. But otherwise it's looking fine. It's a lot cleaner inside, so you can actually see what's going on. Let me clean these plugs, and we will fire up the frequency generator and fire up the scope, and we'll see how it's looking. Hopefully it's looking better. Alright, so I have connected everything up. Still on the square wave. We should still see a square wave. Oh, speaking of which, should actually turn the light off. Remote controlled light. Pretty neat, eh? Anyway. So, let's turn it on. So, interestingly enough, to turn this on, you actually turn on using the scale illumination switch. I had no idea. It's actually a potentiometer. And yeah, it's a potentiometer and a switch. So look at how it just springs to life. Isn't that beautiful? Apologies if there's any wind noise, as I know that can be kind of annoying, but let's wait for it to warm up. It's going to take some time, as it's a vacuum tube scope, but if we just give it a second or two, it should warm up. It's truly a beautiful piece of kit, eh? So, hopefully, I've maybe not restored it to its former glory, but really gotten it close. Let's see what happens. Hey, it's warming up. It is warming up. Let's zoom in on the screen real quick. Let me turn the scale illumination off, just so you can see the screen clearer. And I'll crank up the intensity. And would you look at that? It's staying there. It's not moving. Nothing's happening. We fixed it. We fixed it. I mean, it's such a great feeling when you fix something, but it's even better when, after things have been going so wrong, you finally fix something and it doesn't go wrong. It's a really nice feeling. It really, really is. I mean, it's staying there. Let's try change it to a triangle wave. We'll see what we get. Wow. Just look at that. Turn down the intensity just a little bit for the camera. There we go. And now look. Intensity can be adjusted without it causing problems. And it hasn't even changed or faded since. So that was pretty successful. Now, let me show you something ultra beautiful. So you guys are going to love this. Let me turn off the other lights so you can see it even nicer. So, here's the screen, doing what it should be doing. And here is where everything would be connected. Now the faceplate needs a very good clean, but otherwise, it's looking good. But here's what's something super beautiful I want to show you. It is so beautiful. You'll never see this in any modern equipment. Look at that. Isn't that so pretty? You've got all these little lights glowing and making heat. And look at the difference in them. And these are all the heaters in the tubes. So you can see the heater in this tube is like a disc. This one is probably just a little filament coil. And so in the rest of them. Excuse my shaky hands, I'm really excited. I mean, look at how beautiful that is. And there's more. You can see even down here, the way they glow. It's really cool. Even inside the CRT tube, which is this. And I'm not going to touch it because that's very dangerous. And this is why I really, really, really have to point this out. Do not go playing around in things that use vacuum tubes if you don't know what you're doing. I've been taught on how to be safe around them, and I have a basic idea of what I'm doing. So as you can see if I can get it closer. So this is a bit hard to see as the filament's all in the back, but you can definitely see it through there. Isn't that pretty? Now let's look at the bottom. Okay, so there's no more tubes at the bottom. You can just see the sheer scale of this thing. It's so beautiful. It really is. Now let's look at these ones. Now this is something I'm a bit scared of doing because I'm reaching over the scope. And you can see all of these ones just glowing away. Oh, no way! Look at this. There is a neon lamp over there. And it's glowing. Wonder what that does. But man, this thing is so beautiful. I say what we do is we put it back together and clean it up really nicely. Oh, but before we do that, I must put on the new power cable. So, let me put it back together and we can put on the new power cord.
My stoner mind.
Okay, so the new power cable went on really nicely. The scope's looking good. I just need to clean it and put it back together, so that's what we'll do now. But I've cleaned all the controls that I suspected needed cleaning, so they are looking a lot better and not being finicky. The knobs are very dirty. I don't know why. It's got the same sort of gunk that the connectors have on them. So I'm going to try see if maybe cleaning it with some isopropyl alcohol will get the gunk off the connectors. I'll take off these, because these come off. They're like adapters. They come off like this. So I'll clean these with isopropyl alcohol. But one thing you never do with Tektronix scopes is clean the faces with isopropyl alcohol, because that can rub away the text and the numbering. So you don't want to do that. So, yeah. Otherwise, it's looking nice. New cable's on. It's a little bit short, the new one, but otherwise that should be not a problem. So, let's clean it and put it back together. So, something pretty crazy happened. While I was working, while I was cleaning, the knobs on the front at least, they broke off. Yeah, some of them broke off. Which is these two. So, yesterday, while I was filming, I decided, well, I'd probably not be too chuffed with this, and I was a bit frustrated. So I super glued them and said I'd wait for tomorrow. So now it's the next day. Here are the knobs. Now, we might... Oh dear. Might need to maybe file them down or something. Maybe use a bit of sandpaper. Let's try a file quickly, see if that helps. Just to get rid of some of the solid super glue, because they're too wide to now fit flush, which is an issue, which hopefully we can fix. If not, we can always 3D print these knobs, well, these little like shaft pieces, because these little shaft pieces are actually what broke. And I did check, they didn't break right off the... They didn't break right off the potentiometer, which is good, because I was worried at first that that's what happened. But luckily, they didn't, which I'm very thankful for. Let's see if this will fit in now. Still just a tad bit tight. Let's see. Because what I'm hoping is that the super glue went in the cracks and sealed it from inside the cracks and not just from completely outside the potentiometer. So I'm going to have to do this to the other knobs to hopefully get them to go inside the chassis. Otherwise, I'm going to have to 3D print some new ones, because they've got a special way of coupling to the inside potentiometer. So, yeah. Let's see if this works now. Still just slightly too thick. Yeah, so I'm going to work on these, try get these open, and, well, get these a lot thinner. Hopefully that works, and we'll see what happens. Because these are meant to slide in like that and go onto these potentiometers. Because, first of all, what I need to do is I need to slide them in, turn the potentiometers down to the 0 position, and then align these knobs with these ones. So hopefully I can get that right. My main hope is that that same thing doesn't happen to this one, as this knob is a little bit tough to turn. And I don't know why, but this one should be fine. I would also be worried about this one as well, but that one seems to be okay, so we're going to leave it at that. But, yeah, let me get these knobs smooth, and we will come back to that. So I'm going to get these knobs all smooth and flush in my dad's workshop, because he's got, like, sanding paper and all that, and I don't have that. So I'm going to quickly do that, and then once these knobs are back in, we'll get straight back to the cleaning. Okay, so this video got incredibly delayed incredibly fast. And I can explain why. So, the knob did break. Like you saw in the last video, you saw I struggled a lot. Well, the little shaft, I mean. And I also got sick, so I was ill for the past 3 weeks, which wasn't fun. But that's all fine. I'm better now. I might still be a bit croaky, but otherwise I should be fine. So, here are the knobs. These ones broke off. Well, the shafts broke. This is an original shaft, but when I tried supergluing the other one, this one didn't fit either. So, luckily, the potentiometer inside has the same geared end inside it. So we just modeled a new shaft of this. And now, I've got some 3D printed new ones. So these fit on sort of a little something like this. They fit on quite snug too. I'm not going to push it all the way in, as I might need to take it out. But what we're going to do is we're going to fit these on the scope, and we're going to fit them on this knob, this potentiometer, these three, because this one doesn't use that. But I do need to line up all of the knobs, because if I don't, then these will not be sitting in the right place, and also I don't think these potentiometers are all the way to the 0 position. So I just want to 0 them and put these new knobs on. So let's do that. Okay, so the knobs are back on and aligned. Now, there's one issue though. I was taking these thingies off and I heard a cracking noise and I was like, oh, it's probably just these old shafts. But it was not. It was the knob. And since I think these are Bakelite knobs, it chipped quite badly on the one side. So, just put a little bit of super glue there to stop from cracking anymore, but I did damage the one knob. But otherwise, it doesn't look too bad. It's this one right here. You'll probably see it when I clean it. But, as you can see, all the knobs are working fine. So we've got scale illumination, intensity knob, and beams focus. So that's pretty much everything that needs to be done to the scope to get it fine. So now we can properly clean it, and we will start with the front and the back, but I'm also thinking of maybe we put it all back together and start cleaning it with the side panels on, because otherwise it's all fine. It should be alright, yeah. Because I'll just clean it with the front panels and all of that, as I just want to re-clean them. But I need to put some stuff back together, so I'll put it all back together so that no water or anything can get inside. So, let's get started. Okay, so I've put the panels back on, and sorry I bumped the mic, that must have been quite loud. But I've got the side panels back on, and let's take this outside to clean, because I'm going to just use dish soap and some warm water. As these scopes, you don't want to clean them with anything too aggressive, because that rubs away the writing. And I find dish soap and water works quite well, because I'll use the dish soap and warm water for the first sort of clean. Then I'll use just some regular water, just so I can, I want to say, rinse it off in a way, because I don't really like the sense of that sort of soapy residue sitting on the scope. So then it'll just be some warm water. And then after that, I'll take a dry cloth and just wipe it down. But it went back together nicely, and I'm sure you saw in the time lapse, I did actually plug it in just to test it, because it has been 3 weeks, and it's been sitting on my workbench in pieces for quite some time. So I didn't want to put it all together, clean it up, and then all of a sudden, oh, damn, it stopped working. But no, it hasn't. It's still working fine, and that signal is so clear. So what I'll do is I'll use a microfiber cloth to also clean the screen, and we're going to get all these knobs and everything nice and cleaned up. So, let's go outside and do that.
My stoner mind.
Okay, so I've connected it up and it's all working. I didn't want to let you see it warm it up because it is fine, I know that. But there's the intensity control is a little bit wonky, so it still works fine. It's just you see the one channel cuts out before the other one does when they should be sort of equal. But, I mean, that's alright. Maybe it just needs a little bit of extra cleaning. But it's working and you can see both channels on the screen. And I've turned off all the studio lights. There's just the one room light. And let me show you how. So here we've got channel 1. And yeah, that is pretty bright, so I should turn it down. Because usually it should sit at something like this. At this sort of brightness, because then you don't risk burning in the CRT. But otherwise, it's doing fine. Let's maybe try a sine wave. Look how much smoother that is. So now to just show you the other channel, I'm just going to move that one off the screen. And I will move this one up. Now you can see there's a sine wave, so we can see how it looks. And all the controls are working too. And we can, let's say, increase that. And there we go. And we can make it bigger too. Wrong channel. There we go. Now isn't that cool? So we have successfully restored a Tektronix scope from the late 50s to early 60s. Thank you guys for watching. I know it was a long video, and thank you for your patience with me, as so as life goes. But thank you all for watching. I really hope you enjoyed it. Have a good one. Bye-bye.